Okay, so in this video, we're gonna go through this question from CJC paper 2, 2023 prelim. Yeah. Okay, so we're given this function, okay, y equals to e to the power of negative x sine x plus x minus 1. Okay, and we want to show the second derivative looks something like this, right? So let's just take a look at this function first. In order to differentiate this, for this part we need to use product rule, right? We just eyeball it a bit lah. So we need to use product rule for this first part, this first term. The last term will turn into a 0, right? d dx negative 1 is 0. Okay, and then the middle one is just going to be 1. So let's just differentiate this. To do product rule, we're just going to differentiate the first guy, right? So e the minus x, the negative sign will come down, and copy the sine x. Plus, we are going to differentiate the other guy. So sine x will turn into cosine x. The plus x will turn into a plus 1. Negative 1 will disappear. This is the first derivative. To get the second derivative, we want to differentiate this again. If you want to, you can like factorize stuff, but I don't think it's useful. So we're going to treat it just like this, and we are going to do product rule on the first term. Okay, so let's do that first. So d2y dx squared. This is going to be, we'll just leave the negative sign outside. I will leave it outside. I'll open a bracket, right? And the first, okay, so I just treat it like this, okay. So treat like that. And I'm going to do product rule on just the stuff inside the blue bracket, the blue parenthesis. Okay, so in this case, this is the same as just now, right? So the answer will be just this whole thing here. So I'm just going to copy it down. Negative e to the power of negative x sine x plus e to the power of negative x cosine x. Okay, with the negative sign all the way in front. Okay, the next term, okay, this case, we also need to use product rule, and it's quite similar, but we just want to be very careful when we do this. When we differentiate the first e to the power of negative x, we will get negative sign. Okay, so e to the power of negative x cosine x. And then when we differentiate the cosine, we will get a negative sign. Okay, and then the plus 1 will disappear. Okay, this one d dx 1 will be 0. Okay, so this is the second derivative. We want to just clean it up a little bit. Let me just expand. This will give you e to the power of negative x sine x minus e to the power of negative x cosine x minus e to the power of negative x cosine x minus e to the power of negative x sine x. And we see that we have e to the power of negative x sine x minus the same thing. And we are left with negative 2 e to the power of negative x cosine x. Okay, and that's our answer with k equals to negative 2. Okay, because the question gave us this form, just that they want us to find what is this k. And so k is negative 2. In the second part, we want to further differentiate this result and find the Maclaurin series up to the term in x cubed. So to do this, right, first of all, when you do repeated differentiation for Maclaurin series, usually there's quite a lot of workings, right? Quite a lot of things to write down. So finding a good way to present your answer is quite important here. And what I'm going to do is I'm going to split the page into roughly 2 halves, okay? Or you can split it into, like, let's say 2/3 and 1/3. I'm going to leave all the y's and the dy dx and the, you know, all the derivatives on the left hand side. Okay, so I'm gonna write all of these down, and actually the first 3 we have found already. I'm just going to like copy it down here, right? So let me just copy it down. The d2y dx squared will be this one that we just found. You know what, I'll just copy this. Okay, So we have these two. It's a bit too big. Okay, never mind. So we have this. Okay. Okay, so I have this. Right. So I'm just gonna copy it here because later on when I do the right hand side stuff, right? The stuff on the right hand side of the page, it'll be easier for me to just refer like this. But before I do that, let me just find the third derivative, which is going to be quite simple. I'm going to leave the negative 2 outside. And when I differentiate the e to the power of x cosine x, I should do product rule. So negative e to the power of negative x. Right, I'm going to do product rule. So I'll get negative e to the power of negative x. And afterwards, okay, I will copy the cosine x. I'm going to add e to the power of negative x, and I differentiate cosine x, I will get negative sine x. I'm gonna expand this bracket, so I'll get 2e negative x cosine x plus 2e negative x sine x. If you want to, you can factorize. I don't think it's important, right? Because this is not actually what we need. What we need is we want to find out what are all these derivatives evaluated at x equals to 0. So we want to find, essentially we want to find everything evaluated at x equals to 0. This way of writing this this vertical bar with x equals to 0 at the bottom, that just means something evaluated at x equals to 0. dy dx evaluated at x equals to 0. So it's just a nicer way of telling them that you're going to sub in x equals to 0. Okay. Right. So for the first one, when we sub in 0, sine x will be 0. Okay. Let's just, we're going to see this quite a lot. So let me just put down here that sine of 0 is going to be 0. Okay. Cosine of 0 is going to be 1. E to the power of negative 0 or power 0 is 1. We're going to use these three quite a lot, so let me just put it down here. So the first one, okay, y evaluated at x equals to 0, this will be 0 plus 0 minus 1, so it'll be negative 1. Okay. dy dx evaluated at 0, the first term will be 0 because of sine x. Second term will be 1 times 1, so 1, plus another 1, so there will be 2, positive 2. The third one, or the second derivative, e to the power of negative x will be e to the power of negative 0 will be 1. Cosine 0 will be 1. So it's negative 2 times 1 times 1. Negative 2. Okay. For the third derivative, sine of x will turn into a 0 when you sub in x equals 0. This one will be 2 times 1 times 1, so 2. Okay. So we are done with the workings. We want to now write down our Maclaurin series. So whatever you have, okay, if you want to expand it using Maclaurin series, what you need to write down is this is equals to itself evaluated at x equals 0 plus x times first derivative at x equals 0 plus x squared divided by 2 factorial times the 2y dx squared at x equals to 0 plus x cubed divided by 3 factorial the 3y dx cubed evaluated at x equals 0. Okay, it's in your MF26, so just in case you don't remember this, okay, this is in MF26. Okay. But in MF26 they write it in the f of x form lah, so it looks a little bit different. Okay, what we are going to do is we are going to drop the terms at the back, right? Drop these, and we want to keep up to the x cubed term. The first term will be a negative 1, okay, from above. The second one will be a x times 2, so plus 2x. The third one will be negative 2 divided by positive 2, so that will be just a negative sign, and then x squared. The last one, right, will be a positive 2 This is a 1 times 2 times 3. The 2 will cancel out. You have a 1 over 3. So 1 over 3 x cubed. Plus. Okay. Plus 1 over 3 x cubed. If we drop all the terms at the back, you should write this as you should write this as approximation. Okay. But if you want to write plus dot dot dot, then you just write equals. Don't change to approximation because you haven't rounded anything off, right? You haven't dropped anything. So this is the answer. Okay, let's look at the next and last part of this question. By using the result in part B and the standard series from the list from MF26, we want to find the expansion of this thing here, right? So let me just copy this down. And we should realize that actually the numerator is just from our previous part, right? So this numerator is from the previous part, and this is equals to, which is just above here. So negative 1 plus 2x minus x squared plus 1/3 x cubed plus dot dot dot, of course. Okay, so we have the numerator. The denominator, okay, this is actually from MF26. We want to use the cosine x, right? Cosine x expansion. I will write down cosine x first. Later on, we'll replace with 2x. It's just substitution. So cosine x is 1 minus x squared over 2 factorial plus dot dot dot. And we are going to ignore the higher powers because, I know we're going to ignore the higher powers, but you can kind of tell because you only want up to x cubed. So x to the power 4 you can just ignore. Okay, but it's okay if you didn't realize that. You can just, work with a few more terms and then drop all of them at the very end. Okay. So let's just take note that this is 2x and we will need to replace the x here, right? Okay, so let's do the expansion. In the numerator, we will have the same thing. So negative 1, 2x, negative x squared, 1/3 x cubed. I haven't dropped anything yet, so I put a plus dot dot dot. I'm going to leave the equality here. Okay, over. I'm just going to copy down 1 minus x squared, but my x is 2x. So 1 over x squared, 1 over 2x whole thing squared divided by 2 factorial plus dot dot dot. Now, what I can do is I can just drop these terms, drop these, drop these, right? Now, if I drop these terms, then I need to approximate because it's kind of like rounding off, right? You drop a bunch of decimal places, you are rounding off, right? Okay, the numerator will just be everything except for the other terms that we dropped. So like this. Okay, don't need to write the plus dot 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 anymore because you dropped them. Now the denominator will have two terms. I'm going to bring it upstairs, right? I'll write it as 1 minus something to the power of negative 1. And in this case, this is a 2 at the bottom. We have 2 squared, so 2 times 2. We cancel the 2's. We are left with 1, 2. And then we have x squared. Okay, from here, this is usually how you deal with, this is usually how you deal with, denominators in, let's say, series expansion questions, right? So usually in the denominator, you might have like a bunch of stuff, right? Usually, you expand the expression at the top, expand the expression at the bottom, and you get a bunch of terms. Okay, the good thing is that in the numerator, what you can really do, right, is this is a big fraction. You can just split it into multiple fractions. Negative 1 over this plus 2x over this, negative x squared over this, right? You can split into fractions, but the denominator you can't really split, right? So, or rather, you can't really split that easily. So what you should do is to just drop the terms in the denominator, drop some terms in the denominator, and then you write it upstairs, right? Write it as a negative power, basically. Okay, from here, we know that from MF26, we have the binomial expansion. Binomial just means two terms. So whenever we see two terms, like 1 plus x in the general case to the power of n can be anything. So 1 plus x, this is expanded into 1 plus nx plus n times n minus 1 to the divided by 2 factorial, x squared plus dot dot dot. Okay. To do this, okay, we're going to treat negative 2x squared, okay, negative 2x squared as the x here, right? So we're just gonna be careful about it and substitute accordingly. So negative 1 plus 2x minus x squared plus 1/3 x cubed. And when we expand that, we will get 1 plus n. Okay, n is actually up here, so this negative 1 is the n. Okay, so negative 1 is the n here. Just be careful when you substitute in. We have negative 1 times x. X is negative 2x squared. Okay, plus negative 1 minus 1, so negative 2 over 2 factorial. Okay, and then x is negative 2x squared. Okay, and we square. But actually, we don't need the last term. So if you realize that we don't need a last term, I think I accidentally copied it down without thinking about it. But this one is x to the power of 4, right? Okay, x to the power 4 term, right? So we drop. Okay, drop. So we just ignore it, like we don't write it down later on, okay? So what we have here is if we drop those terms at the back, okay, we also drop the plus dot dot dot. Okay, and what we have is now negative 1 plus 2x minus x squared, and 1/3 x cubed. Now the second bracket will just be 1 plus 2x squared. Okay, to expand this, usually what I'll do is I will treat it like this. I'm going to take every term here, multiply by this first term. I'll write in one row. So negative 1, 2x, negative x squared, 1/3 x cubed. Now what I'm going to do is I'm going to change to take everything here, multiply by the second term, and I'll write in the second row. Okay, so first row and then second row. And the reason is just so that I can make things neater. What I'm going to do is, this is in increasing order of x, right? So when I take all of these terms multiplied by 2x squared, okay, so like for example, negative 1 times 2x squared, that will be x squared term. I'm going to write it here, just so that we can be a bit neater. I take the second term, 2x, multiplied by 2x squared, I will get plus 4x cubed. I'll write it in the x cubed kind of like column. The rest of them are going to be higher powers, which I don't care about, so I don't need to evaluate them. Just acknowledge that they are there. And then, after I acknowledge that they are there, I'm going to drop them. Okay? So, I acknowledge that they are there just to show my understanding. Okay? If you want to, you can immediately round off and just ignore this. But for me, I prefer to just write it down and acknowledge that it's there first. So, if I drop those, I'm going to round off again, right? So I'm going to drop terms, I approximate. I just need to add up the, it's kind of like, you do your like addition in primary school. You just add like this, right? So yeah, that's exactly what it is. Makes it a lot easier to keep track of your terms. And in the end, you will get, this is 13 over 3. You will get this. Because we already dropped the terms at the back and we approximated, I can just double underline here. I don't need to write the extra plus dot dot dot. And that's all for this question.